In this question, they have asked to find the input impedance from this direction. In order to find the input impedance, we need to take the voltage source and need to find the current, and we can determine the impedance from that point. Z is equal to Vx divided by Ix. Okay, let's try to solve this thing. So we'll give a input voltage and we'll try to find what is the current flowing through this. So as the op amp is ideal, the current flowing through this node will be 0. Let's try to remember what are the idealities of op amp. If we consider an op amp, idealities are input impedance is infinite. If the input impedance is infinite, the current flowing through that node will be 0 and the gain will be infinite. The open loop gain will be infinite for ideal op amp. Those are the conditions which we need to take in this circuit for now. So the current flowing through the node, positive node is 0 and the current flowing through this R3 will be Ix only. So the complete current will flow from R3 only. This is V out, right? This voltage is V out. Now for ideal op amp, if the gain is infinite, we can use virtual short concept. So whatever the voltage at this node, the same voltage will come across this node also. So what is the voltage at this node? It will be Vx, and the same Vx will be appearing at this node. So this will also be Vx. So we'll simply do the nodal analysis and we'll try to get the current Ix for the Vx input voltage. Now if we see the current is passing in this path, so this Ix will be equal to this Vx minus V out divided by R3, right? I think it's making some sense. Now we'll find the current in this path also. The current through this node will be, through this branch will be 0, as we discussed, since it's an ideal op amp. Now this will be 0 minus Vx divided by R1 will be equal to Vx minus V out divided by R2. Now we can solve this thing. R2 into Vx is equal to R1 Vx minus R1 V out. Now takes this side will be Vx of R1 plus R2 is equal to R1 times of V out. Let's substitute this equation. This is the next equation which we got. We substitute this V out in place of this V out. Then we will get the relation between Ix and Vx. That's why we are trying to eliminate the V out term in it. So now we can go through this like directly. I'm taking common Vx. Okay, just be aware of the calculation. Vx into 1 minus, here this is multiplied with 1, this is V out, there that term need to be written there, R1 plus R2 divided by R1, and in denominator we have R3. We'll try to solve this thing. Ix will be equal to Vx into R1 minus R1 plus minus R2 divided by R1 both divided by R3. R1 will get cancelled and we'll left with Ix is equal to Vx into minus R2 divided by R1 R3. Vx divided by Ix will be equal to impedance Zin, which is equal to minus R1 R3 divided by R2. This is a negative impedance circuit. We got impedance in terms of negative. This circuit is very interesting and important circuit, which there is most probability that they can ask in interview. So be prepared. Thank you for watching the video.